Good morning. Welcome to our 15th Fusion Friday. My name is Brian Mokopinsic.
I'm Alex Alvarez.
And who's ready for the Super Bowl this weekend? Yeah! Patriots versus the Eagles. Because I only watch football like once a year when the Super Bowl is going. Yeah.
Not a real sport.
Yeah. But the commercials are really cool and all. But anyways, who's excited about this Fusion Friday? I know I am. Because we're doing not one, not two, not three, but 4-axis milling. Yep. So before we get started, I want to remind you guys that you always have the option to ask questions in the GoToWebinar chat room, and then we will be able to answer them in the end with a dedicated Q&A. So yeah, with that said, let's go ahead and pass it on to Alex here, and we'll get the ball rolling.
Perfect. Thank you for that, Brian. All right, so before we do get started, just a quick overview on Fusion 360, right? So it is a product that takes you all the way from the design stage of the product to manufacturing, right? If you take a look at that workflow, that could be anywhere from 3, 4, maybe even 5 different tools, depending on the company that you're working for, right? But with Fusion 360, you bring that down to one tool, giving your team a much more integrated experience, right? So Fusion 360, if you weren't aware, it is connected to the cloud. So what that means for you is that you can ultimately leverage the technology, right, or the computing power that comes by being connected to the cloud. Now, connected also means connecting people. So again, being that you are connected to the cloud means for you and your team that you do have access to your data in one seamless, easy to access environment. So then finally, Fusion 360 is accessible both on Mac and Windows platform. So you don't need to run boot camp on your Mac on your MacBooks anymore to access some of this engineering software, right, or engineering technology.
Also, don't forget to download the Fusion 360 app. You can access all of your data on your phone, and you can show anyone a 3D modeling view of your data that once you save it in your computer, for instance, you can access it instantly on your phone.
Right. So that's cool. Yeah, and that's going back to being connected to the cloud, right? And having access to your data wherever you go. So like Brian mentioned, today we are going to be talking about 4th-axis milling. So it's a pretty common topic. A lot of machine shops have access to maybe some sort of rotary table or some sort of 4th-axis capabilities, right? So that's why we decided to touch up a little bit on this topic. So some learning objectives for today. Some common mistakes, right, that we see when people set up their 4th-axis parts. We're also going to walk you through how to do that, and then finally post out the program to your machine, right? So 4th-axis milling, this is again your typical setup that you would see at a shop. You would have some sort of rotary table. The part is going to be the one that's going to be rotating or spinning on the table there. And while it's spinning, that's essentially when you get your 4th-axis, right? So if you guys take a look at the diagram, we get essentially what is a rotation about the x-axis, which in turn gives us some sort of a value, right? So now that a value is going to be in degrees. So again, you're going to start off with your work coordinate, your initial position, and then you're going to have to rotate some sort of degrees in order to get to your next feature for your machine, right? So 4th-axis milling can be broken up into substitution or simultaneous 4th-axis. So essentially, substitution is indexing, right? So you rotate the part and then stops rotating and you start machining. Whereas in simultaneous, you have both all 4 axes working simultaneously, right? Now you don't just have a 4th-axis rotary table. You do have something along the lines of this diagram as well. Now, the specific name for it, I'm not too sure, but you do have it. That's where the head of the machine has access or the ability to tilt, right? So it is going to be rotating some sort of degrees about the y-axis. Now, this is important because in your post, if you are the one that's doing the post modifications, you do have to essentially write that down in the post or take note that the head is the one that's going to be moving and it's going to be rotating about the y-axis, right? So it's really important to really figure out where the rotation axis is going to take place. All right, so some common errors. The most common error that I do see is this error message, right? Direction is not supported for machine configuration. Essentially what that means is that you selected a face, right? So let's say you were doing indexing. The word corner system, if you take a look at it, it looks okay, right? The x-axis is running, and looks like it's running directly through the center line of the part. But again, if you go ahead and post it, it's going to give you an error. Now you wouldn't know because you're looking at the top view, so everything looks fine. But as soon as you rotate views, take a look at what happens, right? So the x-axis is tilted some sort of degrees. It's not running through the center of the part anymore, right? And then that's why you get that error saying that it's that the direction is not supported. So this is pretty obvious. You can clearly see that it's not running through the center line of the part. Now, again, there's going to be times when it's not this obvious, right? So what I do recommend, and if you do get that error, is try posting using a 5th-axis post, right? If you see any sort of change in the C value, that means that the x-axis wouldn't be essentially running through the center line of the post, right, of your program, of your part. So that's one way to kind of debug the error there. And again, that's if it's not as obvious as you see here. So let's go into Fusion then and walk through some of these toolpaths. All right, so this part was done in the modeling environment of Fusion 360. I added the rotating table here as well as the tailstock just for visual preferences. Again, you don't have to do this, right? This isn't necessary, but if you sometimes want to verify exactly how close you get to maybe your chuck or the tailstock, this can come in handy, right? So again, you do have access to that chuck actually in your cam samples of Fusion 360, right? So if you guys haven't been here, I highly recommend you take a look through, at some of the work holding that is available to you guys, and explore, bringing in some of the work holding or vices for your models here. All right, so I'm gonna get rid of some of this stuff, make it a little bit easier to program. Right, so again, model this in Fusion 360. You can see the design history over here on the bottom. Let's go ahead and just jump directly into the CAM environment of Fusion 360. Right, so here again, pretty intuitive workflow, right? We're going to be working from left to right in the sense that we're going to create our setup, add some toolpaths. Again, if you do have Fusion Ultimate, that's one thing that I didn't mention, is that 4th-axis and 5th-axis milling only happens with Fusion Ultimate, right? So if you don't see the option later down the road, you'll see what I'm talking about. But if you don't have the option to set your tool orientation or to work with wrap toolpaths, that's because you have the standard version of Fusion, and you don't have capability or 4th and 5th-axis capabilities, right? So again, if you want those capabilities, then Fusion Ultimate is going to be the answer for you. But turning does come standard with Fusion 360, as well as 2D profiles, right? So you got your water jet, your laser, or your plasma cutters. You do have the ability to work with 2D profiles in the standard version of Fusion 360. So once we laid out the toolpaths, we're going to want to simulate and make sure that we don't have any collisions, make sure that we're cutting properly, and then finally post out your program, right? So again, let's go ahead and get started with the setup. So if you were new to this interface or just new to machining in general, we got what we call these tooltips, right? Which essentially guide you as you're creating some of these programs. Right? So for this, we see that we're going to be setting up our work corner system as well as defining our stock, right? So that's what we want to do. Let's go ahead and get started. So by default, we do get this square shape for our stock. You can go ahead and change that, right? You can do a fixed size box, fixed size cylinder. Again, you have a couple options here. But what I've done is I've modeled the stock that I was going to essentially use. Right? So here I have it modeled. So in our case, we can choose from solid. And now this comes in really handy, right? If you have some sort of cast a stock that's from a cast, or you've already done some sort of operations on your stock, you can just go ahead and model it inside the modeling environment of Fusion 360 and bring it into the CAM environment here, right? Okay, so our work corner system then is telling us that it's going to be on the center of the cylinder here. We can go ahead and change that to a selected point. And I want the center of the front face here, right? Automatically, we see that we get that position there, right? So another thing you could do then is take a look at some of the features that we have here, right? So we have this flat pocket, we have this angled cutout, as well as this coil going around the part, and then this wrapped pocket on the other side, right? So what we can do is, instead of having the machine rotate, let's just have this be the top of our z-axis, right? In other words, make the z-axis perpendicular to the top face of that, so that way we don't get any rotation when the first operation happens, right? So what we can do then is set this as select z-axis, right? So now it's asking us to select something that's perpendicular to the z-axis. We can go ahead and hide our stock. Click on this face, right? And now we have the correct coordinate system there, right? Make sure that you do have the body selected, or else you are going to be running into some issues. Now, if I would have started with the stock visible, you would have had both bodies selected, right? So you always want to make sure that when you're selecting your stock, either have it turned off, or you make sure that you have the correct bodies here selected for the for your setup. All right, so click OK. We get a preview of how it looks. Again, so we have a couple of indexing features as well as simultaneous features in this part, right? So you can many ways that you can work on this part. I'm going to go ahead and split them up between indexing and simultaneous. So I'll get all the indexing work done first, and then I'll jump over and do the simultaneous programming, right? So for this first feature, again, there's not much to do, right? You just rough out and then do some sort of finishing operation. So let's start off with a 2D adaptive clearing. Selecting your geometry, we want to machine this pocket. Right. We get this blue shading indicating to us what we're going to be machining. And it is going to be machining pretty deep into this material, so you can add some sort of ramping as well as taper to your ramp, right? So that's going to provide for better chip evacuation, and you're not going to have these chips cluster right here as you start machining lower towards this part, right? So that looks good. We can leave some material both on the wall of the part and on the floor. And we get the appropriate toolpath there, right? Okay, now let's go ahead and do some sort of finishing operation. You can go over here to the top, select the 2D pocket operation, right? Or I could just right click and select derived operation. Again, so essentially what this does is that it's going to select the same tool, same feeds and speeds, same selection, just a different toolpath, right? So 2D pocket by default, it does have this check for leaving some stock, which it's going to be a finishing operation, right? So we don't want. And then it's going to helix down into the part. The only issue here, though, is that the top height, it's still picking it up as a stock top, right? So we've already removed material here. What we can do then is just select which face is going to be the top of it, and we can just add, let's say, 100,000 to that offset, right? So now it's just going to be a small helix into the part there, right? Okay, so we have our roughing strategy and our finishing strategy there. All right, so now working through this part, we can go ahead then and take care of this angled cut. So let's go ahead and do that. We can use a 3D adaptive. So again, essentially the difference between a 2D and 3D toolpath is that the 3D toolpath looks at the entire model, right? And it looks at the stock that you have predefined for your model. And then when you select the toolpath is going to get as close to the model as it possibly can, right? Removing as much stock as possible. Whereas a 2D toolpath, it doesn't look at the model, right? You have to select some sort of pocket or some sort of chain in order to drive that toolpath. Right, so for 3D toolpath, we're again using our roughing strategy. Selecting our tool. Let's go ahead and use a half inch flat. Right, so then this is where the fun stuff comes into play, right? So the next tab is going to be the geometry tab. Now we need to select tool orientation, right? So again, tool orientation, if we select this face, what's going to happen, right? We're going to have the z-axis, look at it, perpendicular to it, right? So we have the z-axis. You can kind of tell that the z-axis is already pointing off at an angle here, but the x and y are, would seem perfectly oriented, right? If we go ahead and rotate it, we see that that's not the case, right? Yeah, we get the x-axis going off in, into space somewhere over here at a certain degree, right? So again, in order to properly get this toolpath, we need to create some sort of plane that's parallel to the XY plane, right? So I believe I already have one created here, so we can just go ahead and turn on the visibility. That's the plane that I used to split the part up, and this is a plane that's perfectly perpendicular to it. Right, so now instead of having that face selected, we can go ahead and select the plane that we used. And now for geometry, we're going to be selecting this edge here. All right, we get a preview. And now typically we have center on boundary, right? So let me go ahead and just select center on boundary just to show you guys some differences. All right, and then again, another big tip that I usually tell customers or people that I'm working with is with 3D toolpaths, don't go off and select, you know, or change multiple options at once. The reason for that is that 3D toolpaths can be a little bit more complicated. So with that, again, if you get an error, you're not going to know exactly which option you changed, right? So you have to go back, maybe you have to start all over with the 3D toolpath. So start off small, make a few changes here. So the only change I made in this toolpath is the tool orientation, and then I just selected my chain, right? So I'm not going to worry about these other 3 tabs for now. Now, as I'm looking at this model as well, I see that the z-axis is pointing in the wrong direction, right? So all we have to do is either click on this on the head of the triad there, or just select flip axis, right? And then just click OK. All right, so we get this toolpath. Again, we selected tool center on boundary, right? So our boundary was this outside chain, and in return, the toolpath then is staying within that boundary, right? Or the center of the tool is staying within that boundary. All right, so decent looking toolpath. The only issue is it's helixing into the part, right? So that may or may not be what we want. Again, if you have some sort of work holding over here, that would be the only option in that case. But for us, we have it on the chuck and on the center point or the tailstock in the back, right? So we can come in from the sides and machine out the material from the outside of the stock. So let's go ahead and change that then. Again, quickly going back into the toolpath and then just changing to outside boundary, right? Clicking OK, and we get a better looking toolpath, right? So again, you can change this, these high retracts by changing the linking parameters to minimum retraction and adding some sort of micro width, right, of 100 thousandths possibly, and avoiding some of these high retracts. Okay, so we have this toolpath. Again, with this, you're going to have some sort of scallop as you go up this face. So you're going to have to come back and do some sort of finishing operation, right? Whether that be parallel or some sort of more spiral or some of these other more lengthy toolpaths, right? So another option then would be rotating the part a certain amount of degrees and machining this way, right? So that's that would be the more efficient way to machine this part. So what we can do then is create a sketch, which I already have created here, right? And then just machine out this material vertically, right? So again, it's gonna it might be a little bit lengthier for the roughing operation, but again, you're not going to waste 15, 20 minutes on the finishing operation trying to get a nice finish on this face, right? So again, you can go up here, create a 3D toolpath, 3D roughing strategy, or you can just go here, right, create derived operation, or you can even copy the toolpath, paste it. You could have done a duplicate, right? It would have just copied the toolpath again. So you have a lot of options here to play around with when trying to be more efficient with your programming, right? So for this, again, all you have to change then is the tool orientation, right? So now we don't want that work plane. Now what we want, let me turn the origin back on here, is this plane here. And deselect that chain and select the chain that we had created, or the sketch. Again, we're going to be machining using outside boundary. Everything looks good. Now for this case, I did extend the tool a little bit. What you could have done is selected a shorter tool, right, and not machine all the way down to the part. Maybe machine halfway, a little bit further past halfway of the part, and then rotated the part 180 degrees and machine the other side, right? So that's the neat thing about 4th-Axis, is that you have a couple options to play with when it comes to machining this part here, right? So where in another case you would maybe have to set up a fixture or maybe a vise to do some of this machine. Here you can just rotate the part 180 degrees after the first roughing operation, right? So again, for this case, it is going all the way to the bottom. So now what you can do then is just have the contour just coming around here and just finishing up that face. So you can select it to the contour. Again, using that same tool, contour selection. Notice if I hover over this sketch, it highlights the entire sketch. I don't want it to do that, so by holding the Alt key, right, you move on to a single selection, right? So you see that the line isn't exactly following that path that I selected. So again, you have to enable tool orientation, right? So select the XY plane here, and see that we get the appropriate looking tool path, right? Okay, and for this, you can just go ahead and click OK. Notice that it is on the other side, so what you can do here then is go back into the Geometry tab and then just flip the Z-axis. Okay, all right, and we get the appropriate toolpath, right? So now we have to rotate it and finish the other side. So let's go ahead and duplicate that toolpath, Control D. We have the same toolpath duplicated. Now all we have to do again is flip the Z-axis and maybe change the height a little bit. So we want to go lower by, let's say, 100 thousandths, right? We don't want to leave some sort of line there or mark there indicating to us that we are just machining half of the part, right? So go down a little bit below it to get rid of that, and we see that the tool is going through the part, right? So again, let's change that. Be careful when selecting your chains. Again, you have to make sure that the arrow is pointing in the correct direction here, right? So now taking a look at the bottom view of this, you see that it's 100 thousandths below that face there, right? So we can go ahead and simulate what we have so far. Let me go ahead and suppress this toolpath here so it doesn't simulate. Yes. And then simulate the toolpaths that we have. Okay. So here we have our flat pocket. We have an angled cutoff face. And then we have our contour operations finishing that off, right? Okay, so we're making pretty good work on this part. Let's see what else. Okay, so the last portion of the indexing moves would be this drilling operation, right? So let's go ahead and take care of that. Let me hide some of these sketches. Okay. So now what you can do then is let's take a look at the setup, how our word coordinate system is set up. Okay, so we don't have a hole that is directly normal to our word coordinate. So again, we're going to have to make sure that we select the tool orientation for this for these hole operations, right? So going into a drilling operation, again, I forgot the size of the hole. You can simply hover over the hole, 0.332, selecting the tool then, drill Q, click OK. Right? If we were to click on the hole right now, click OK, it's going to fail to generate, right? So again, it's not normal to our word coordinate, so it's not going to pick that hole up. What we have to do then, go back into the drill operation and again, enable tool orientation, right? Okay. We have the correct toolpath here. Again, if you were to select same diameter, you would get error messages because these holes aren't in the correct plane as our word coordinate system, right? So the way to get about that or to overcome that issue then is by doing a circular pattern. Right? So new pattern, it's going to be a circular pattern. Our axis, you can pick the center of this hole, and it's going to be 4 instances. Okay. And we see that we get the 4 holes created there, right? You can go back to your drilling operation, make changes. Right, we want to drill the tip to the bottom of the hole by, let's say, 50 thousandths, and the entire pattern changes as well, right? So we pretty much finished the indexing moves here. So now let's go ahead and jump into some of the more complicated geometry here. This is the simultaneous motion. Okay, so again, now working with wrap geometry, right? So let's go ahead and start off with a roughing operation. The tool that we're going to be selecting is a 1/4 inch flat. And now for geometry, right? So typically when working with wrap geometry, I recommend selecting the cylinder first that we're going to wrap about. So again, if you have Fusion 360 Ultimate, excuse me, you are going to have access to this wrap toolpath, right? So with this, you're able to select the outside cylinder, and now just simply select the geometry that you're going to be machining, right? Again, we get a preview of what's going to get machined. Notice for this, I didn't have to select tool orientation, so that's because it was wrap geometry, right? So it automatically knows where the toolpath needs to be contained from, right? So we selected the tool, we selected our geometry, and we selected our cylinder to wrap our sketch or our geometry about. And okay. One thing I did notice though is that it's under the pattern folder here, right? So you can just simply drag it out, make sure it doesn't pattern that, so that around, right? So here we get the roughing strategy for that coil, right? So now again, coming back in here and doing a finishing operation on the walls, I left 10 thousandths on the wall here. So again, creating a derived operation, right? We're trying to do this as accurate as possible, but also as quickly as possible, right? Setting this using the 1/4 inch flat. The bottom height is going to be the selected contour, but we want to stay above maybe 1/2 thou. Right? We don't want to rub the tool on the floor and get some unwanted marks here as it's going around. Again, it's going into the pattern there. You can close that, collapse it. Okay. You can simulate these 2 toolpaths, right? So you can select individual toolpaths to simulate by simply holding Control and selecting the toolpaths that you want. Going up here and simulating them, speed it up a little bit. Again, it's showing the tool doing the rotating as opposed to the part, right? So hopefully in the future we'll see some machine simulation where we'll actually see the part be the one rotating, right? That'd be nice to see. So here we see that we get a finishing operation on the walls there, right? Again, it looks like we have some like graphics card error there. So you can see some bleeding through the part, right? So now that we're done with this section, let's go ahead and work on this wrap pocket, right? So this is going to be the wrap pocket. Again, you can just simply do a drive operation from this one. Let me bring it below the contour, and then just edit the geometry, right? We're going to be machining, not that chain. Put this chain in here. We're going to be leaving 10 thousandths on the wall, and then just simply click OK. All right, we wrapped around the same cylinder, and then we just created our toolpath here, right? So again, duplicate this contour, right? It's a lot of repetitive work here. Then deselecting the chain and selecting the chain that we want to machine.
So moral of the story is Control D, use what you've already got.
Yeah, use the toolpaths that you already got and some of the options that you already selected. Something even easier would probably be to do templates, right? So now templates work a little bit better on turning, where you have a profile that you're going to machine, maybe some holes that you're going to be drilling or boring out, as well as spacing operations, right? So with milling, it does get a little bit more tedious, but if you already have working recipes, like let's say, your linking parameters, or maybe some the heights controlled for some of these toolpaths, you can just go ahead and create some sort of template for this, right? So now when you're working on a part, simply select the chains that you want to machine, and then delete some of the toolpaths that you're not going to be using, and make much better use of your time that way, right? So that's another option to use. Control duplicate is a pretty big one for me. Okay, so for here, looks like we already have that toolpath there. All right, so then finally, it looks like we would have to go ahead and work on this text here, right? So again, for that, engrave would be a good one, right? The only thing is, though, that you don't have that wrap toolpath capability in engrave, right? So unfortunately, it's only going to be vertical to the machine or to the tool. It's not going to wrap this text around the cylinder, right? So then the other option then would be to use a 2D contour, right? So again, selecting your tool, using this 1/4 inch, you can use this 3/8 inch, right? And then selecting your geometry. Now, with 2D contour and text, I found it somewhat counterintuitive selecting some of this geometry, right? So again, selecting the cylinder that we're going to wrap about, and then the geometry. Right, notice how it begins selecting some of this individually, right? So you can go ahead and select this, and it only selects that edge there, right? So what you can do then is just click on that edge again. Notice that it's open contour. Go ahead and change that to a closed contour, and hover over some of these edges until you get that entire closed loop, right? Click OK, and doing that again one more time. And then just selecting until it closes, right? So I'm gonna do a few of these just to get the point across here. So selecting the edge, it's gonna be a closed contour, right? And then just adding that. Make sure that you do accept that current contour selection. Otherwise, it's just gonna be that single line or these two edges that you selected, right? All right, so last one here. Change that to closed contour. Do that. Okay, so bottom height is a selected contour. You can either change that, or it's a little bit easier to stock to leave, right? So this is where we're actually going to use stock to leave to machine a little bit deeper. So we can go anywhere from 2 to 5 thousandths with this tool, right, to do the engraving. Click OK. And we get the toolpath there, right? You can't really see it because, again, it's 5 thousandths below that. You can go ahead and change some of the lead ins and lead outs that we have for this. So now it's following directly on that lettering there, right? Okay, so it looks like we're almost done. The last step then would be to create this chamfer. So again, let's go ahead and do a 2D contour, right? Using that same 3/8 45-degree chamfer mill. Geometry, let's go ahead and select this edge here and wrap toolpath, right? What happens? We get an error. So this is a kind of a bug if you tell me, right? So it's a little bit cumbersome to come back in here and really get this toolpath to work. So there are a couple options to go around it. One would be to use tangential extension, right? So you can use 2D contour, right? If you had maybe some sort of a small arc here, then it would be able to use tangential extension and then just extend it, the diameter or the radius of this edge here, right? So that's one option there. Another option would be to create geometry that isn't fully closed. So that's the only reason why wrap geometry didn't work, was because it's a closed circle here, so it wasn't able to wrap the geometry and then work properly, right? So let me see if I have that sketch created. Yeah, so I do have it. So what we can do then is go to 2D contour. Geometry is going to be this edge right here. Make sure you wrap the toolpath. Right, so we got a preview here. Okay, click OK. And there we get the correct toolpath, right? So again, let's go ahead and simulate some of these toolpaths. What I like to do also is turn off the body, right? So we get a better visual representation. You can change the material as well, right? So the color of this ceramic, I find that this is a little bit better to really visualize, and change that to gray, right? So simulating some of the stuff, again, let's get that. Okay, skipping that one. All right.
So you've pretty much done like almost all the tooling on this part.
Yeah, pretty much. So here we see the chamfer. What you can do here is, again, use tangential extension and extend that toolpath a little bit further, right? So it looks like we got some error here on point. So yeah, it looks like it plunges into here. So what you can do then is just make sure that you go back into the T and have the correct, yeah, okay, so looks like I selected the wrong geometry there. Change this back. And going back, editing, you don't have to deselect everything here. Oh, that's the issue here. Okay, so simply click on this, delete the current chain, select another chain, right? Edit, maybe close contour. So now we get the appropriate loop here, right? So there we go. Another important topic that I wanted to touch on, right? So with flat pockets, the toolpath that we selected is going to work fine, right? But with wrap geometry, if you guys were to machine this, right, and exactly how it is, it's not going to clean up this edge here perfectly, right, or this wall right here perfectly. So What I mean is that you are going to see some sort of gouging on this wall, and that's because this wall is directly pointing to the center of this cylinder, right? So to get a better visual representation of what I'm talking about, right? So this is how wrap geometry would work. Think of this as our tool. Right? So if you were the one modeling this part, you have to keep in mind of the tool that you're going to be using, and for the wrap geometry, make sure that you create that perfect offset to this tool, right? So essentially try to model this radius here, or try to match this angle of the tool. Again, so with wrap geometry, you typically have the edges pointing towards the center of the part, right? You have the center of the tool pointing directly to the center of the part as well, because that's the definition of a 4th-axis mill, right? So when you select your contours, obviously you're going to have some sort of gouging here, right? So if you select, again, it's important to which edge you select. If you select the top edge, you're going to get more gouging. If you select the bottom edge, the tool tries to compensate and machine somewhere in between, right? So you're still going to get some sort of this little slither of material here left on the top, and then some sort of material here removed on the bottom, right? So again, if you don't have access to 5-axis machines, the best you can do really is do some sort of 3D toolpath and try to scallop down. Otherwise, if you try to do this, you are going to see some sort of gouging into the part, right? All right, well, let me go back here and post out the code. Right? So last step then, posting out. You do have a couple options here, right? So the most common one that I've seen a lot of people use are Haas A-axis. But again, depending on what machine you're running, what controller your machine is using, you are going to have to use that specific post, right? So if you don't have access to that post or that A-axis post, try to go into the Autodesk HSM post library. Proceed to it, right? And then just try to see if the post is somewhere inside this library, right? So again, if it's not, feel free to reach out to us, and that's something that we can help you out with. We do modifications for posts as well. So again, if you don't see your post in there, or you want some small changes, don't hesitate to reach out.
Yeah, and also just for those of you who don't know, HSM is built into the CAM as the backbone here in Fusion 360. So it's essentially almost the same thing.
Mm-hmm. Right, so posting out the code, we see here that we have the program, right? So the first pocket, again, like I mentioned, it was directly perpendicular to our work coordinate, right? So we didn't have to rotate. Let's see if I can show a couple more, please. So then the next adaptive, right, we get some sort of rotation in the A-axis, and so on and so forth, right? So I also enabled G187, right? So that's a built-in user property inside of Fusion 360. So if you guys do use G187 for your Haas machines, feel free to give that a try as well. Right? All right, so that's pretty much all I had for today. Just a quick overview of what we did, right? Setting up your 4th-axis part to run on your 4th-axis machine. So we also went over some of the common mistakes that people make when really programming or setting up their parts, right? You want to make sure that you do have a correct setup when doing these tool paths, right? And then finally, we posted the code out and made sure that the A-axis was working properly. All right, so here at Cative, like Brian mentioned, we do consulting, right? So one of the things we offer here at Cative is Fusion Boost. So essentially what Fusion Boost is, it's a service that's attached to the seat of Fusion 360, right? So with Boost, you do get an introductory call, right? It's typically an hour long. We go over the user interface of Fusion 360, kind of walk you through how to set up some of your projects, some of your user preferences. We also have fundamental training once a month. So that's a 4-hour training that you can use for yourself, right, to get up to speed on Fusion 360. You also have access to 4 1-hour sessions with either Brian or myself, and that can really be covering anything you want, right? So whether how to set up your part, maybe some of the best options or the best techniques to model the part that you're currently going to do. Again, whatever you want to talk about in that 1 hour, you do have access to both Brian and I, right? So we also check up with you once a month or twice a month, depending on how often we communicate. But we want to make sure that you're using the tool, right, and that you're using it to its full potential. So again, if you go onto Autodesk, you will see that the price for Fusion is $300. But here at CATIV, we sell it for $499, but that's with Boost attached, right? So again, with Boost, you get all the services that I just mentioned. And then if you need Fusion Ultimate, that's going to be $17.99, but again, it also has Boost attached to it as well, right? So
yeah, and if you already have Fusion and you want to get Boost, you don't have to get another seat of Fusion. You can just get Boost itself.
The Boost portion,
Boost service itself, correct.
Yeah, so now if you guys have any questions, feel free to ask them. If not, you guys can always reach out to us, whether it's Fusion 360 or really any Autodesk manufacturing software, right? We're here to help. We want to make sure that you guys are successful in using this tool. So whatever question or issue you're having with the software, feel free to email us.
Yeah, it looks like we have 2 questions different people asking the same question here. Is pretty much how are you able to access the 4 and 5 axis in Fusion? Does it come in the standard version of Fusion?
Yeah, so it doesn't. Unfortunately, 4th and 5th axis capabilities only come available in Fusion Ultimate. Right, so just the differences between Fusion Ultimate and Fusion Standard are some more advanced simulation, right? So if you're looking for advanced simulation where you actually want to see your product, or you actually want to see how these 2 objects or 3 objects are interacting with each other, that would be advanced simulation, right? So for that you would need Fusion Ultimate. And again, you would need Fusion Ultimate if you want to do 4th and 5th axis machining.
Yeah, and if you guys missed any of this video and you want to pretty much watch it, go ahead and check us out on YouTube, CATIV Fusion Fridays, and we'll be posting this video once we're done editing it here. So,
absolutely.
Yeah, if you guys don't have any other questions, thank you guys for watching.
Yeah, hopefully it was informative for you guys. Hopefully you guys learned a thing or 2 that you guys didn't know before.
Yeah.
So.
All right.
All right. Thank you guys for tuning in. See you on the next one.
Take care.